Dear students, today we see the different types of the transitions in the IR spectroscopy. So these are the various different types of transitions. Based on this, the IR spectroscopy is manufactured or it gives the characterization results. So first is the rotational transitions. So these purely rotational transitions can occur in the far infrared and the microwave regions. That is, they are between the 100 micrometer to the 10 centimeter. It is a range of rotational transitions where we can see where the energy is insufficient to cause vibrational or electronic transitions at or below room temperature. Molecule is usually in its lowest electronic state, energy state, called the ground state. It is denoted as A0. The pure rotational transitions will occur at the ground state electronic level, although it is also as possible to have the appreciable population of the excited states of the molecule where only the rotational transitions occur. Discrete absorption lines will occur in the spectrum, the wavelength of each line corresponding to particle transition. The fundamental information can be obtained about the rotational energy levels of the molecule. This region has been a little used analytical in the IR characterizations techniques. So next, it is a vibrational transition. The same like as the energy is increased, wavelength is decreased. As the energy is increases, the wavelength is decreases. Vibrational transitions occur in additions to the rotational transition. These vibrational transitions are with the rotational transitions with the different combinations of the vibrational rotational transitions. Each rotational level of the lowest vibrational level can be excited to different rotational levels of the excited vibrational level. In addition, there may be the several different excited vibrational levels, each with number of the rotational levels. This leads to number of discrete transitions. The result is spectrum of the peaks or the envelopes upon resolved fine structure. The wavelength at which these peaks occur can be related to the vibrational modes within the molecule. These occur in the mid and the far infrared regions. Some typical infrared spectra are shown between this range. So it is a rotational transitions and the vibrational transitions. So these are rotational transitions. It is observed between the 100 micrometer to the 10 centimeter range, and in a vibrational, so this it occurs with rotational vibrations. Then third is electronic transitions, and this electronic transition is still higher energies. So it is observed between the visible and the ultraviolet wavelength. So there is a different level of the electronic transitions takes place, and the rotational and the vibrational transitions are the superimposed on this. So in the electronic transitions, all the rotational vibrations are occur with the with these vibrations. That means they are the superimposed. This results in an even larger number of the possible transitions. Although all the transitions occur in the quantized steps corresponding to discrete wavelength, these individual wavelengths are too numerous and too close to resolve into the individual lines or the vibrational peaks, and net result is a spectrum of the broad bands of absorbed wavelength. A typical visible and the ultraviolet spectra are the shown with electronic transitions due to lack of the structures. UV visible spectra are not particularly useful for the structure determinations. However, they can be used for the confirmation by comparison with the spectra of the competitive compounds. Comparative compounds. So these ultraviolet visible spectra, it doesn't give complete information about the functional groups, but with other characterization techniques, we can take the characterization of UV with the IR spectroscopic techniques.